I'm going to take you through the process of modeling, analysis, and design of reinforced concrete structure using the software ProtaStructure. I'm going to show you how to import drawings from AutoCAD, how to rename your axis, columns, and beam. I'll also tell you the difference between primary and secondary beam. I will show you how to hinge your beam members, that is, how to release moment and save cost. I'll also show you how to insert wall load, story, and wind load. And finally, I will tell you the governing principles in reinforced concrete design. I'm Miracle Okeke Richard. Welcome to SamGoz Engineering. And in this channel, I help you develop the required skills and enhance your knowledge to elevate your engineering career. So if this is what you want, you can quickly subscribe. This is the building we'll be modeling using the software ProtaStructure. And in our previous video, we have done the structural framing. That is where we placed our columns, beams, and also slabs. And this is it. And in that previous video, I shared the governing principles relating to column placement, beam, and also paneling. And in previous video, we found that this column, this column, this column, and this column, they will terminate at the ground floor. They will not continue at first floor, which are these columns on red color. Then we now introduce a new column, which are these ones on magenta, and these ones on magenta are called floating column. Reason is because they did not start from the foundation level, they started at the second floor. So any column that doesn't start from the foundation level is called a floating column. And in previous video, I was able to disclose the governing principle relating structural framing, and in this video we will be modeling this using the software ProtaStructure. So let's head over to the software ProtaStructure. Once I open the software ProtaStructure, I will click on New Project. So I'll click on New Project and I'll allow it to load. So I want to name this project. I want to use the name YouTube. Let me just call it YouTube 1. Let me use the name YouTube 1. And then you now select the code that you want to use. And in this video, I'll be using United Kingdom. That's Euro code. This is the code I'll be using in this video. So I'll click on OK. And this is the ProtaStructure interface. So right now, all we'll be doing is to import our structural framing that we did in AutoCAD into this ProtaStructure software. So first, we'll go to building setout. Once you go to building setout, you click it. You now come under external reference drawing. You click external reference drawing. A diagram box will appear. Then you now click on add DSF. You know that we saved our file as DSF file because ProtaStructure only recognized DSF file. So once you have gotten our file, we will locate it. We saved it on our desktop. You click your desktop. So this is our file. So I'll click on it. Once I click on it, I'll then click on open and then allow it to load. So it has loaded, but if you can see, you're not seeing anything here. So I'll click on this active button. So once I check this active, this will appear. Then if I want to turn on my color, I'll turn on my color from here. I can increase the capacity of the color lightening or decrease it from here. Look at it, I've decreased it. This increasing it a little bit, it will appear here, but I want to leave it at maximum. Then since once I've imported my DSF file, next thing to do is to go and import my grid line and my column. So importing grid line and column, I'll click on this place named import. So I'll click on it. Once I click on it, a dialog box will appear. So this is my grid. So I saved my grid line as grid YouTube. I'll check it and then click on OK. Then why my column? I saved it as column YouTube. So I'll deselect this and then leave this one. I'll click on OK. So once you have selected your grid line and your column, you come and click here, import. So once you click on import, you allow it to import. So it's importing. So let's wait for it. It has imported. So we now click on close. So right now we also click on OK. So it has imported. So another thing, the next thing to do now is to rename this axis, but you can only rename this axis if you are using ProtaStructure 2025. So to rename this axis, I'll come to this place review and I'll now come and select relabel members. I'll click on it and then I'll check axis because I want to relabel axis. I'll come here, move it to 1. I'll then click on OK. So let's watch. As you can see now, it's now 1 2 3 4 and ABC. So we have renamed our axis. After renaming your axis, next thing to do is to insert your beam. So we can easily insert our beam by we'll come to model, then we'll now come and click on beam, then we'll click on normal beam. So at this point of At this point we want to insert our beam. Then they're asking us what is the breadth we want to use. So in this case I want to use the width of my block wall, which is 225, so I'll just type 225. So this is the width I would like my beam to be. That's the width of my block wall. Then I'll now come to this space, height, which is the depth of my block wall. So remember, our aim is to save cost. So in saving cost, we'll first of all go with the minimum beam depth. And to the minimum beam depth we have is 300 millimeter. Then in that minimum beam depth, we now have minimum beam depth is 300, then plus the depth of slab. So minimum beam depth, which is 300, plus the depth of slab, which is 150. So 300 plus 150 will give us 450. So here I'll be using the depth of my slab to be 450. It is gotten from minimum beam depth plus the depth of your slab, and we know that minimum beam depth is 300. Don't forget the reason why we are using minimum beam depth, that is 300 plus 150 giving us 450, and minimum column size, that is 225 by 225, is for us to save cost, and that is what the code specified too as the minimum size. So but this is what we'll be using. But if it fails in cost of our design, therefore we will not increase it. But to save cost, we will be using minimum. Then if it now fails during design, then we will not increase it. If the beam fails, we increase the beam depth. If the column fails, we will not increase the size of column. So don't forget, our aim is to save cost, while safety is still our priority. So right now I'll then come and connect all my beams. So I'll be having this, but I want to run it through. I'll also run it through from here. I'll click on escape and then run from here to here. Then I will also drop it here. So this is a cantilever. If you can see now, you'll be seeing this arrow sign. This arrow sign indicates a cantilever. So this is a cantilever. So this small beam now is a cantilever that will be carrying this beam. So this small beam and this small beam, they will be cantilevers that will be carrying this beam. So but let's continue. You still get to understand. So I'm having from here to here. I'll click on it. Then I'll join it to this place. So these two small beams, they will be carrying this beam. So I'm also having from here to here. Okay, let me show you something now. Let me drop this here. As you see, if you can see now, I'm having that this beam is a cantilever, but this beam I don't want it to be a cantilever. So what I will do now is that I'll just highlight this and delete it. I'll just click on delete. So I'll double click on this one to bring out this property. I'll first of all connect a beam to this. So I'm having this now. Then I'll now come and connect this. If you can see now, that arrow sign is no longer showing. Reason is because we have not made this beam a secondary beam. Look at this beam now is a primary beam. The reason why it's called a primary beam is because it is connecting two columns. That's it is resting on two columns. Why this is resting on a column and on a beam. So this is our primary beam and this is our secondary beam. And to this secondary beam is acting as a point load to this secondary beam is acting as a point load to this primary beam. So first, in your modeling, you make sure you first of all connect the primary beams first. Then you now connect this secondary beam. If you connect the secondary beams first, that cantilever sign will be showing you that it is a cantilever. So first of all, connect your primary beam. So I've explained the difference between primary beam and a secondary beam. So let's continue. If you can see now, I did this one first from here to here, which is primary beam. As me, I did this one first. That means that cantilever sign will be showing. So but I don't want it. I'll connect it. Okay, let's use it here. If you see now, I've seen that cantilever sign. Reason is because this thing is serving as a cantilever. But if I first of all connect this, then I'll not allow this one to rest on it. But remember, if I'm connecting this one is not a primary beam, because it is not connecting two columns. It is resting on this beam. So this is a secondary beam, and this too is a secondary beam. But the difference is that this secondary beam is carrying this secondary beam. So in this case, for these two beams, this is my primary beam and this is my secondary beam. Why for these two beams, this one is my secondary beam, why this is my primary beam. Hope you are understanding. So let me do Ctrl Z to remove this. Then I'll double click on this to bring out its property. I'll first of all connect from here to here. So and I'll also connect from here to here. Then I will connect from here to my goal is just to connect all my columns. Then I'll also connect from here to here, and I'll also connect from here to here, and I have this beam connect from here to here. This beam will be carrying this slab. Then okay, I have this beam connect from here to here. Yes, I think we have to do, okay, see here, I'll connect from here to here. So okay, look at this, I'll also connect from here to here. So right now we have modeled all our beams. So yes, we are through. We have modeled all our beam. Next thing is to insert our slab. So I will escape. So next thing is to insert our slab. So I'll come to modeling and then click on slab. So once I click on slab, they are telling me to define load case or to assign load case. I'll click on yes. So once I click on yes, I'll just come here and click on loading generator. So it will generate the road for me automatically. So in this vertical road, leave all these things as default. You see, they are all gotten from the code. They are all gotten from the code. So leave them as default. Then in terms of this horizontal road, assuming I'm having, so I'll only check this wind road if the height of my building is above 10 meters. So if the height of my building is above 10 meters, that means it will be affected by wind. But since this is a duplex, it will be the first floor is 3 meter and the ground floor is 3 meter. So it's not up to 10 meter. It's not, the building height is not up to 10 meter. So therefore, I will not check this wind load because it won't be affected by a wind load. So I'll just since the vertical ones, leave it at the first, then the horizontal one, if you're having wind load, you check it. Then I'll then come here and then click on OK. So it will automatically generate the road for me. I'll then click on OK. So a dialog box will appear here. So once my dialog box appear, then the height of my slab, I would like to use 150. I would like to use 150 as the height of my slab. Relative level, leave it at 0. Then under loading, we'll come input our dead load. So dead load is gotten from partition load. Dead load is equal to partition load plus finishing load. So partition load is within the range of 0.5 to 1, while finishing load is within the range of 1 to 1.5. Yes, do you understand? Finishing load is within the range of 1 to 1.5, while partition load is within the range of 0.5 to 1. But in this case, I would like to be using finishing load to be 1 and partition load to be 0.5. So if you add both of them, you'll be having 1.5. So this now is the self weight of slab. So the software have automatically calculated the self weight of our slab for us, and the self weight is gotten by the unit weight of concrete times the depth of your slab. So the software have done that automatically for us. So this. Remember, finishing load is just something like ties, terrazzo, and the rest. Then I'll come and right click on this impose load. So I'm designing for a general domestic use building, that's a residential house. I'll click on this. Then roof load, I'll leave it because this is the country where I am. We don't have all this adverse weather, so I'll leave the roof load at default. I'll leave it at 0 because there is no snow here and all this. But if I'm in a country where I'm having all this snow, I'll likely increase my roof load. So with this now, I'll then come and click here to input my slab. Click input my slab. Click input my slab. I'll be clicking, and also I'll be clicking. So it not appear here. I'll click here, but don't forget, this is a staircase vision, so we won't apply any slab here. So after this, I will close this. So the next thing now is to hinge our members, to hinge our beam. So now listen, let's explain this. Let me explain this way now. If you can remember, summation of moment at any point is equal to 0. If you can remember that, summation of moment at any point is equal to 0. So let me come to this point now. At this point now, we'll be having this moment going in this direction. We'll be having a moment. We'll be having a moment going in this direction, and this side will be having a moment going in this direction. So one will be positive and the other one will be negative. Something like we'll be having positive 30 kilonewton here, and this side we're having negative 30 kilonewton. So if you sum both of them, since one is positive and the other one is negative, if you sum both of them, you'll be having 0. Yes, because the summation of moment at any point is equal to 0. So the same thing with here. There is a moment like this. That's if you can remember your social analysis. That's in your university level. We're having a moment like this and also a moment like this. One of the moments will be positive and the other one will be negative. For example, positive 20 and negative 20. So if you sum both of them will give you 0, because there is a rule that says that the summation of moment at any point will give you 0. I say summation, I did not say moment at any point. Moment at any point will not be 0, but the summation of the moment is equal to 0. Then coming to this point now, we are only having one moment at this side. If you see now, this is not a continuous beam, like this beam did not continue from this side, so therefore there is no moment here. So since you're having only one moment here, and remember the rule that says summation of moment is equal to 0, that means this moment, the moment here, is automatically equal to 0. I don't know whether you understand what I'm saying. I said here now we'll have, let me say for example, we'll be having a moment here, but we should have a moment here and a moment in this direction. But in this case, we are only having beam in this direction, but there is no beam in this direction. So what it means that the summation of moment at this point is equal to 0. So the moment here that we have here, that it means that it is 0. Why here now the moment we have here can be 30, why the one we'll be having here will not be negative 30? If you sum both of them, it will give you 0. Why at this point we don't have any moment here, and the moment we'll be having here will be 0? Because the summation of moment at any point is equal to 0. So for that reason, ProtaStructure doesn't know that here, that there is no moment here. Like it's taking that the moment at this point is not equal to 0. So we now have to tell ProtaStructure see that the moment here is equal to 0. The moment also at this point is also equal to 0. So by doing that, for example, look at it, this is I end, and this is J end. So I will just click on this beam, I will right click, and I will say I will come to update beam end condition, and I'll say hinge at left end, which is I end. I'll click on it. I'll now click on apply to the selected beam. You see now, if you can see now, you'll be seeing this red dot here. So what it implies is that we have hinged this member. One of the advantage of hinging your member is that it will help you save cost. Remember, I told you as a structural engineer, first thing is safety, second is economy. So you have to be economical in what you are doing. Don't waste your current money. If you don't hinge this point now, you'll be having higher reinforcement. Because if you do not hinge here, ProtaStructure will not recognize that the summation of moment here is equal to 0. ProtaStructure will take it that there is a moment here, and you know that the more the moment, the more the reinforcement. So if there is a moment here, ProtaStructure will counter for the moment here by providing more reinforcement. I don't know whether you understand what I'm saying. So you have to hinge here so that ProtaStructure will know that here is hinge and will not provide any additional reinforcement here. But don't hinge this point, because the summation of moment here is equal to 0, but the moment here is not equal to 0. It is the summation that is equal to 0, not the moment. Here now the summation is equal to 0, and also the moment is equal to 0, because if you sum up the moment here, it will give you 0, and 2, there is only one moment here, therefore that one moment will be given us 0. I don't know whether I've been able to do justice to this explanation. So we know that in drawing this beam now, if you want to draw this beam now, you'll be having, it will be going like this. It will come here, it will go up, which is high moment, it will also come down, it will go up, hugging moment, it will also come down, then it will now come and terminate here, which is there. If you can remember your university days when you are drawing bending moment diagram, your bending moment diagram will go like this: go up, hugging moment, come down, sagging moment, go up, hugging moment, come down, sagging moment, then terminate at 0. I hope and I believe that I've been able to do justice today. So therefore, I'll be applying hinge to all these things. So this one now, I'll be hinging here, and I'll be hinging this end. And for this beam now, I'll be hinging this end and this end, because this is a simply supported beam. So the moment in both directions is equal to 0. So I'll come here and click on hinge both end. I'll come here and I'll click on apply. So I will just select everything. I want to select all the simply supported beams. That is the beams that I'll be hinging both directions. So let me select this one again. This is a simply supported beam. You hold your control key, you select this. This is a simply supported beam. You select this. This is a simply supported beam. You select this. This is a simply supported beam. You select this. I want to select all the simply supported beam. So I will hinge it at once, not hinging one after the other. Sorry, this is not a simply supported beam. So I'll hold my control key and deselect it again. So I want to select all my simply supported beam. This one is not a simply supported beam. It is continuous until it's carrying a cantilever. So if it's carrying a cantilever, please don't hinge it. Don't hinge a cantilever, because we know that cantilever will be having a hugging moment. Yes, it will be having reinforcement at the top. So don't hinge a cantilever. So this is a simply supported beam. I'll hinge it. This is a simply supported beam. I'll also hinge it. This is a simply supported beam. I'll also hinge it. I don't know whether I'm through with all the simply supported beam that I have here. Let's check here. No, this is not a simply supported beam. Not a simple. Not. Okay. Yes. Then yes. Sorry, this is also a simply supported beam. Yes, this is a cantilever. This one is not a cantilever. Is this that is a cantilever, and this that is a cantilever. So this is a simply supported beam. No, it's not a simple yes, yes, but we have hinged it. No, so yes, so we'll now like click, then now click on come to update bin end condition. Then we'll now click on hinge both ends. Where is it? Both ends hinge. So we'll click on it, then we'll now click on apply to the selected bin. So we'll now click on escape. So if you look now, we are having hinge here, we're having hinge here, hinge here. So next, I want to apply hinge to all my I to all my I direction. So I'll click on this. This is I. This one definitely here will not, here will be J. So I will not bother looking at this point. So I'll hold my control key. This one I will not, this is I, but we're having a cantilever here, so I will not hinge here. So this is I'll hinge it. This one is I, but I will not hinge it because we're having a cantilever. This one is I, but remember we have already done this as a cantilever, as a simply supported beam. So I will not hinge it again. If you hinge it again in form of I, that means it will only hinge here. Like that that one you did for both ends will undo, and then it will only, and then only here will be done. So I will leave it. I've done, okay, I have done this. Then I have selected this. This is a simple, this is a, okay, this is a simply supported. This is a simply supported. So I'll not hinge. Remember, I'm hinging only I. So let me come and shake. I is downward. So this is a simply. This is a simply. I'll not touch it. Then I'll hold my shift key. Hold this I. I don't know whether you understand it, but if you're not understanding, you can just do it one after the other. Then I also hold my shift key. Click on this I because here is I. If you look at it, here is I. So I'll also, this is a simply supported. So I'll not touch it. Then I'll come here. Hold my shift key. Click on this I. Yes, I think we are through. So reshake I. Remember this side is I, so I'm having one here. Here it has a cantilever, so no. Yes, cantilever. It has a cantilever. No, this is simply supported. This is simply supported. Simply supported. So in terms of vertical, simply supported. Simply supported. Yes, this is my I. This is simply supported. Simply supported. Simply supported. This is my I. So I'll just right click and then click on hinge update beam condition. I'll now click on hinge at left. That's the I members. Then I'll click it. Click on the apply enter me. So if you zoom well now, look at this IN, it has been hinged. Look at also this IN, it has been hinged. Look at this IN, it has been hinged. Look at this IN, it has been hinged. So the next one we'll be doing now is for J. So I'll come and click on this point. Then I'll also, this is J, I'll click here, hold my shift key. So this is also J, I'll hold my shift key, click here. So this one is also J, I'll hold my shift key, click here. This is simply supported, so I will not touch it. This is simply supported, this is simply supported, and this is simply supported. I'll come to the vertical. Simple, simple, simple. So this is my J. I'll hold my shift key. So remember, I've done here as I, so I won't do it again. And this beam now, this one now is continuous, so we will not be hinging here and here. Then okay, this one is a simply supported, this one is simply supported. So I'll hinge here as my J, and then I'll also hinge here as my J. This is a simply supported. Then I'll now right click, then now click on update. Sorry, I'll then click on update beam end condition. Then let me hinge my J, apply to the selected beam. So once and through hinging my beams, remember hinging your beam will help you save cost. If you do not hinge your beam, you'll not be able to save cost, because if I do not hinge here now, like for example, if I do not hinge here now, ProtaStructure will be giving me something like y, let me say something like 5y16 or 3y20, but since I've hinged here, ProtaStructure will be giving me a normal reinforcement, which is something like 2y16 and so. But if you do not hinge it, you are not saving cost, because ProtaStructure will be providing higher reinforcement, because what it means is that there is a moment at this point, and two, ProtaStructure must surely design to counter that moment. I don't know whether I've explained this beam hinging for you very well. Right now, what I want to do is that I want to see my 3D view of this my modeling. So I'll come here, click on view, right click, then I'll now click on 3D physical model. I'll click on it. I'll wait for it to load. So this is my 3D physical model, if you can see it now. So this is my 3D physical model. So right now, what we'll be doing is to let's go and insert the next story. That is the first floor. Let's go and insert our first floor. So I'll come back to plan. Once I come back to plan, I'll come to this building setup, and then come to story, and then click on it, then click on insert story. Once I click on insert story, number of story will now be 2, because this one now is our first story according to ProtaStructure. So number of story will now be 2. The insert height, the height should still be 300. Then I'll now click generate members from the selected story. I'll check this, then I'll now click on OK. I'll now say yes. I'll now allow this to generate member from the previous story. So this is what it's doing. So this is my story 2 now. Let's go to our 3D view and see. So you can see it. I can see it. Yes. So but you should note that in this 3D view, you should know that now this point, these are our first floor. Then this point now is our roof level, and two, we'll cover this place with zinc. That's our aluminium roofing sheet. So I need to delete this slab because we'll be using aluminium roofing sheet. So I'll select this, hold my control key, select. But if this is taking your time, you can just come here and you can just come to this story too. You can just double click on this story too. Once you then click on slabs. Once you click on slab, hold this, then hold your shift key, to this extreme, then right click and then click on delete, then click on OK. Yes, so we have deleted everything. But don't forget what I told you initially. I told you initially that the minimum beam depth is 300. Yes, the minimum beam depth is 300. But what we are, and two, then we now have our slab depth of 150 added to it, sum it up to 450. But what we are having here is a beam of 450. But we want to be using the minimum depth of beam, which is what, 300. So in order to convert all these things to 300, what I'll do is that I'll come to this 22. I'll then click on beam, right click, then I'll now come ROC beam table. I'll click on it. So once I click on it, a dialog box will appear here. This is the depth of the beam. I'll click on this depth and then click on this person icon. Then I'll change this to 300, which is the minimum beam depth, because there is no longer slab added to this beam again. So I'll click on OK. So everything will change to 300 and then click on close. So if you can see, we have reduced this. Make sure that you do this to save cost. Remember, first, our main priority is safety, and our next priority is to save cost. That's to be economical in our design and not to waste our client's money. But if you can remember, in our ProtaStructure, sorry, in our AutoCAD, when we are doing our structural framing, we have that some columns will terminate at the ground floor. Yes, we have that some column will terminate at the ground floor. We have that some column will terminate at the ground floor, and we have new columns emerging at the second floor. So let's go back to our plan view. So this is the story 2 now. So let's go back to story 1. We'll be going back to story 1. So remember, at story 1, we'll be having cantilevers. These cantilevers will be pulling off from our modeling. We'll be having all these cantilevers at this story 1. So I'll input this cantilever now. So remember, I'll input this cantilever now. So what I will just do now is that I'll come to my slab, go to modeling. I'll come under my slab, click on slab. I'll allow this dialog box to come out. Okay, I'll click on slab. Then this dialog box will appear now. So I will change this to 150. Yes. Then I will now come and select this type 12. This type 12 slab is for cantilevers. I'll select it for cantilevers. So I'll select this 150. Then concrete cover, I'll still leave it as this. Then under loading, remember I've explained this, so I'm using 1.5, and here I'll right click. I've explained it. Roof load, no roof load, because we don't have adverse weather condition here. There's no snow around here. So at cantilever, then the length of my cantilever. Okay, let's shake. Let's go back to ProtaStructure and shake. So let's go back to let's go back to AutoCAD and shake. So we want to know the depth of my cantilever. So my cantilever, that's from here to here. I'm having it as 450 for this one. I'll also right click. From here to here, I'm having it as 600. Okay, and then I'll check again from here to here, 600. So I'm having 600, then 450. So let me go back to my ProtaStructure. I'll go back to my ProtaStructure. So I'll input 450 first. Then what I'll do now, I'll now come and click here, from here to on this point to this point. I will now bring it out. I'm having this. So this is what I'm having. As you can see, this is what I'm having. Then I'll now right click on this thing again. I'll right click on it. I'll right click on it, the same thing, but I'll now come here to bring out its property, and then come here, change the length to be 600. That's what we're having in our AutoCAD from our architectural plan. So this is what we'll be having. Then I'll also connect from here to here, bring it out. This is what we'll be having, and also connect from here to here, bring it out. This is what we'll be having, and also connect from here to here, bring it out. This is what we'll be having. So let's go back to AutoCAD again and shake this dimension for these ones. So I'm having that from here to here is 300, and also I'm having that this side, I think that all sides is 300, is still 300. So I'll go back to my AutoCAD, so to my ProtaStructure. I'll just double click on this cantilever to bring out this property. I'll double click on it to bring out this property. So I'll just come to this point and change it to 300. Then I'll come from here to here. I'll pull it out from here to here. I'll pull it out, and then from here to here. Hey, mistake, sorry. I'll just click on undo. Then I'm having that from here to here. I'll pull it out. So it's complete now. I'll then close. So this is what I'm having. Let's go to our 3D view. So this is my 3D. This is my 3D view. And remember, this is my 3D view. But don't forget, we have that we saw in our modeling, we saw in doing our structural framing, we saw that this column will go, this column will go, these two column will go, and then at the back we'll be having that this column will go, this will go, and this will go. Let's go back to our AutoCAD so you see it. So look at it. We'll have that this column and this column. Then we go, and then we'll now introduce new columns. So let's go back to our ProtaStructure. So I'll go back to my plan view. I want to go back to story one. So as story one, okay, sorry, I want to go to story two. As story two, we'll be having that this column, this column, this column, and this. I will delete them because they will go. Yes, I'll click on yes. So this column, they will go. Then since this column will go, we'll be having a new column that will be emerging from this place. But I want to that my plan to appear here. Look at what I'll do. I'll come here, I'll go to external reference drawing, and then this number of story now, I'll change it to 2. I'll change it to 2. So it will start appearing in this my second story. So let's wait for it. Okay, yes, it's not appearing in this second story because if you can see now, this is that our cantilever line. Yes, it's not appearing. This is that our cantilever line. As maybe you can remember, we have not seen this cantilever line before, and also look at this our cantilever line. And if you go back to story one, you see it will no longer be there. Okay, it has been covered by this. So now, right now we are in story two. Let's just go back to our story two. What we will do now to model, because we have to move this beam to this point, this beam to this point, this beam to this point, all this beam to this point, even this. So for us to move this beam to this point, what we'll be doing is that we'll be creating a new axis on this line. So I'll just click on this, right click, and now click on offset axis. Once I click on offset, I'll just come and place it here. So this is the reason why I modeled this line in my AutoCAD, so I can easily place it, because assuming I do not have this line now, what I'll be doing is that I'll offset this thing 300, offset this thing 500, offset here 600. For me, it will take time, so I'll just offset and just come and place it at this point. So right now, I'll double click on this line. I'll remove this bulb and then click on hide hidden axis and then click on update. So this is it. So this is a grid line. So the same thing, I'll offset and place it here. So this is the reason why I found this boundary in AutoCAD, so that it will be easy for me to model it here in ProtaStructure. So I'll right click and then click on offset axis. I know this video is taking long, but the reason why I'm doing it is for you to understand everything, understand the basis and the governing principle in first concrete design. I'll also click on update, because if I don't explain all these things, I don't think you really understand. Sorry, I'll not click on close. I don't think you really understand the governing principle in first concrete design. So that's why I'm taking my time to explain every single thing. So pardon with me if this video is taking too much time. But if the video is taking time, you can increase the speed of the video so it will be faster for you. Yes, if the video is taking time, you can increase the speed of the video so it will be faster for you. So right now, this is that my cantilever. See my cantilever from here, 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 and I've replaced them with a grid line. The same thing, I'll come and do the same thing to this point. I'll replace these cantilevers with grid line. I'll place it here. Then since I've selected this, I'll right click on property, and I will check off these boxes, and I'll click on hidden axis. I'll click on update. I'll then close. I'll then right click on this. Sorry, I'll right click on this, copy it, click on offset axis. Then I'll place it at this point. Once I'll escape, I'll right click again, click on property, because this one is already selected. I will double click to remove this circular thing, and then update, and then close. So okay, let me also I'll right click again, offset axis, then I will place it at this point. So yes, it's already a hidden axis, so no more need to redeem those things again. So right now what we'll be doing, this is our story 2. So this is our story 2. What we'll do now is to move all this beam to this point, move this beam to this point, move this beam to this point. So you can either move this beam to this point or you introduce a new beam. So me, I want to go by introducing a new beam. So I'll double click on this beam to select its property. So I'll then click that I'm having a beam running from here to sorry, remember we said that we'll be introducing a new columns here. So let me first of all introduce those column. So I'm having a new column at this. So I'm having a new column at this point. Yes, but if you can remember, that column now should be inside. Let me escape that this column now, this column now, like, let me right click. I'll right click. So I'll show you how this column should be. I'll click on property. I'll then click on here. This column should be like this. So I'll click on this and then click on update. Yes, to bring it in. To bring it in. So it will be inside this grid line. So it will be inside this grid line to bring it in. So I will deselect and then I'll double click on this column again. Then place a column here. So once I place a column, I'll come here, change the property. See, this is the property that we should be having. I'll update it. Yes. Then I'll come here again, place a column here. Then I'll come here. This is the property that we should be having. Sorry, I placed it wrongly. So let me do control. Okay, don't worry. I'll delete it. I'll place it here. I believe this is the correct point. Wait, let me check. Sorry, is this extreme one that is the correct point? I would still delete this one better. Sorry. Then this should be the. I'll click. So this should be the correct positioning. I'll click on update. Yes. So I'll delete this. Is a mistake, and I'll also sorry, hold my control key. Then I'll right click. I'll click on delete. I'll click on OK. So I've deleted this. So this is what I should be having. And a column should and a beam will now run through and connect all of them. So I'll double click on this. I'll double click on this. So we should be having a beam. Sorry, I did not place it correctly. I did not place it. Okay, yeah, I see. Okay, I want to place. Okay, I want to have this beam at this point of grid line. So we should be having a beam running from here to here. But if you can see now, this beam is not in alignment. Yes, this beam is not in alignment, and it's not. This edge should lap with the grid line. This edge and should lap with that our grid line. So what we'll do now is that we'll come here, then we'll come and check which one is it. I think it will be this. Then I'll draw up, click on. Sorry, I'll click on update. Yes, so this grid now is not lapping with the grid line. If you see now, this point is not lapping together. Then this beam now will also continue from here to sorry, I should have introduced. Let me escape. I should have introduced this column because this column will be serving as a cantilever. Sorry, I should have introduced a beam here. Pull it out because this beam now will be acting as a cantilever. It will carry this beam that will run through here. Yes, it will carry this beam that will run through here. So I would say escape, double click on this to pick its property. Then I'll move from this point to this point. Yes. The edge is aligning with this grid line, so it's still okay. To this point, yes. Then to this point, yes. Then to it will not terminate here. But if you see now, this is our grid line. Let me escape. This is our grid line, and the edge is moving away. It should move inside. So I'll come here. I'll select this, then click on update. Yes, it now suits in. Hope you are understanding because this is how you now model. So since I've done all this, I'll right click on this, hold my shift key, hold my shift key, hold my shift key. I'll delete all these things. This one too. I'll also delete this one and then introduce a new pin that will run from here to this point. So I'll also hold this and then I click on delete. Then I'll click on OK. Then I'll double click on this beam. So this beam now. So after this, we'll go and see what we have done using the software ProtaStructure. So this is what I'm having now. So this is what I'm having. Let's go and see the 3D view. Let's go and see the 3D view. Let me turn off all these axes. So this will be a clear drawing. I'll come to display. I'll come to layer. I'll turn off grid line. Turn off my ghost axis, plane definition, and text. So I'll be having a clean drawing. So if you see now, let's check what we have done. Yes, so this is it. If you can see now, so this is it. I'll be seeing it. This is the model. Make sure you should not make mistake in your modeling, no, because if you make mistake in your model, that means you'll be having errors in your design. And so because if you make mistake in your model, that means your load will not be transferred accurately. That means you'll be having mistake in your design. It's not like the software will not design it well, but it's designing the wrong thing. Yes, so you have to model your this thing. You have to do your modeling well. You have to take time, model it, understand the structure. So right now, Right, and the next thing that we're going to do now is that we'll introduce a beam here. Introduce a beam here because ProtaStructure, if you leave it like this, ProtaStructure will see ProtaStructure will not run any analysis if a column is resting on a slab. But for if the slab is less than 1 meter, if the cantilever is less than 1 meter, in real life, a column can rest on it. Or in real life design, a column can rest on the slab. But ProtaStructure will not allow you to rest any column on a slab. ProtaStructure has it that all columns must be rested on top of a beam. All columns must rest on a beam. So since that rule that ProtaStructure have, I'll introduce a beam here, a beam here, and a beam here. Let me go back to story one. Don't worry. Once I go back to do it, you understand. So let me turn on my grid line and every single thing. Let me turn them on. I'll then come to modeling again. Then I'll come to my plan. I'll go back to story one. I'll go back to story one. So this is my story one. I'll double click on it. So yes, this is my story one. So what I'm trying to say is that I'll introduce a beam here, and I'll also introduce a beam here, and I'll also introduce a beam here to carry that column. So don't worry, let me just introduce, then we'll now go back. So I'll double click on this to pick its property. I'll double click on this to pick its property. But right now, I want the depth of my beam to be the depth of my slab, so that this beam now I want to introduce it so that it will not be showing in the building. This is for aesthetics, because if someone looks on, if after constructing this building and someone is seeing a beam running from here to here, it will no longer be that beautiful, it will no longer be fine again. The aesthetics will drop, like it will no longer be pleasing to the eyes. So for that reason, I would like to make my beam there to be 150. Yes, to be 150. Remember, I told you that in real life, this slab can carry a column. Any cantilever that is not more than 1 meter can carry a real column. Yes, but since ProtaStructure doesn't allow a column to rest on a slab, that is why I'm introducing this beam. So if I'm introducing this beam, I will introduce it as a hidden beam. A hidden beam is just a beam that is hidden inside the slab. So that's why I'm using the depth of my beam to be 150, because I want it to be a hidden beam. A hidden beam can also, you can also call it slab stiffener. Yes, that it stiffens the slab, it make it more stronger. So you can either call it a hidden beam or a slab stiffener. So in this, that's what I want to introduce here. So I want to introduce it from, I've changed the depth to 150. I want to introduce it from here to here. So yes, it's a cantilever, but we'll just leave it like that. Then here I'm having this. I will also introduce it. Hey, let me double click on it to select its property again. Yes, then I'm having from here to here. So what I will do now is that I will hinge the both ends of these beams that I've introduced now. Reason why I am hinging the both ends of this beam is because, remember, I told you initially that if not that ProtaStructure made it as a rule that you cannot rest a column on a slab, I would have rested this column on this slab, because in real life it's obtainable, it's achievable. But ProtaStructure have made it as a rule that I cannot rest a column on a slab. So that is why I introduced this beam. So if I introduce this beam, I want to now hinge it, because I know normally I shouldn't have introduced this beam, because if I do not hinge it, ProtaStructure will be providing higher moment for this beam. Like if you not hinge it, you can just, maybe on your own, you can just, as you're doing this, you just don't hinge it, you see that this beam will fail. Yes, because you did not hinge it, because moment on it to be high. So I like to hinge it because I know in real life I will not really input this beam. So I would like to hinge it. I'll hold my, but in construction I'll just input it as a hidden beam more. But I want to hinge it because I know it will see sustain. I don't really know that you understand what I'm explaining, but I will just want to hinge it. I'll come to it and click on and click on hinge, both end hinge, because if I don't hinge both of them, this beam will surely fail because the moment on it to be high. So to reduce the moment of this beam, I have to hinge it, knowing the fact that I could have rested this column on top of this slab, but ProtaStructure doesn't permit it. So since ProtaStructure doesn't permit it, and I introduce a beam, then and I hinge that beam so that I'll be having 2y16 here. If you do not hinge this beam, I bet you must surely increase the depth of this beam to 450. ProtaStructure will demand it to keep on failing till you increase the depth to 450. So I now hinged it to be having 2y16 and at a depth of 150. Thank you. So these are the things. So let me go back to my 3D view so you see what I've done. So as you can see, if you see that is you so this one doing construction, this one will be trimmed off. So if you see that this is the beam, is not showing. If you see that is in alignment with the slab depth. So we are through with this front modeling. So the next part we are going to model now. We're almost through with our with our modeling. The next part we are going to model now is this part. That's remember in our architectural plan. Let's go back. Let's go to our architectural plan. So in our architectural plan, see this column stopped at this ground floor, it did not continue. So let's go back. Remember, you can get this CAD file and practice. Get this CAD file and practice. Remember, this CAD file comes with the architectural plan, and also I've done the structural detailing for you in case you are working on, in case after your modeling, analysis, and design, you want to carry out your detailing, you can reference this CAD file. You can easily reference it at any point you are confused. You can make reference to it. So get this CAD file. The link is in the description below, and it is also pinned at the comment section. Get it and practice. Remember, practice makes what perfect. And to master anything, you master anything through repetition. That's through practice. So get this CAD file and practice on your own. It will definitely help you as a structural engineer. So let me go back to ProtaStructure. So these two code, this column and our home life control key, I will delete both of them because they terminated at the ground floor. So I'll delete both of them. I'll click on OK. Then I'll then come to my plan again. Go to my story 2. So this is my story 2. So yes, no, go to my, I'm not yet on story 2. And so this is my story 2. Remember, this is our new grid, and that means we'll be having a beam from here. A beam will now run from here to here to here. Don't worry. Now after we'll go to the modeling, so you understand why I ran a beam here, here, here. So, don't worry. Let's just go. You understand? Let's just model. So I'll double click on this thing, on this beam. I'll run a beam from here to here. But remember, the edge of this beam should align with this. So I'll just come here, click on this, and then click on this, and then click on update. It's not aligning, so it's good. So this one should run from here to this point. If you see it's moving out, it's not inside. So I'll also click here, click on this extreme, click on update. It's not aligning, so it's good. We are good to go. And then click on this one. So we are good to go. So at this point now, I have to delete this, hold my control key, select this, and also select this. Then I click, I will then delete this. I'll click on OK. So since you have deleted this, that means we have to introduce a new beam that will run from here to here. Yes, we have to. Okay, yes, okay. See, we have to introduce a new beam that will run from here to here, and also a beam that will run from here to here. But I would not like a beam to run from here to here, because if this beam should run from here to here, that means it will be serving as a cantilever, and to that cantilever will be carrying a point road, which is this beam, and another point road, which is this beam. So for that, anyway, this is a roof beam, so I think it will be able to carry it. But I don't really want that. So for that, I want to introduce a column here, to minimize, because if I introduce a column here, that means that means this beam now will no longer be a cantilever. So what I'll do now, I'll right click, in which I told you structural design is totally dependent on the engineer. So I'll place a column here. So if you say I've placed a column here, that cantilever sign have gone. So I'll then now I'll then double click on this to select its property. I'll now introduce and I say new beam crossing over other beam. Do you want to split it? I'll say no, I don't want to split it. I'll explain what it means. I'll say no, I don't want to split it. What it means is that if you say yes, you want to split it, that means what it means that if you say yes, you want to split it, that means this beam will now run from here to here and stop, then continue again from here to this point. But no, that means if you do it like that, I don't think this beam will no longer be the one carrying this. So I want this thing to be a straight beam. So it will be that it is carrying this secondary beam. So that's why I say that they should not split it for me. So that this will run from here to here and this will carry this. Because if they split it, that means this beam is no longer carrying this. Do you understand? Yes, this is the ideology. So you have to understand what you are modeling and what you are doing. So we are through with the modeling. So I said that we'll go to 3D view. So you understand why I modeled this beam here. So let me go and explain it to you now. So if you can see now, the reason why we model this beam is because so we'll be having a roof. Remember, this is the former beam, and remember we have a cantilever. So if we do not model this beam, that means our roof will not be covering this cantilever. So for our roof to cover this cantilever, we have to model this beam and delete the previous one. Do you understand? I don't know whether you understand, but I believe that you understand. Yes, I believe that you understand. So at this point we are through with everything concerning our modeling. So this is what we are. Let me turn off everything, so you'll be seeing our modeling well. The next thing is to apply our wall load. So that's the next one we're going to do, and after our wall load we'll come to the end of this video and continue next time. Sorry, let me click on escape. So this is what we'll be having. This is what we are having now. This is what we are having. This is what we have achieved so far, and I hope and I believe that you are understanding our lecture. So this is what we have achieved so far. So the next thing now is to input our wall load. So I'll click on layer again, turn on my axis. Remember, if you do not turn on your axis, if you want to model anything, it will not model. So that once you start modeling and it's not modeling, don't be surprised. Hey, what's wrong? You check whether your axis is being turned on, because if you turn it off, and try to model anything, it will not model. So right now, let me go back to, remember, I'll go back to story one, because it has this story one that will be applying our wall load. So I'll go back to story one. I'll double click. So this is the story one. Then what I'll do now is that I will come here, right click on this, I'll right click and click on edit load. Once you edit load, the dialog box, then it will not take us where we input our wall load details. So I'll click on edit load. Once this dialog box appears, what we want to apply here is wall load. So this is for point load, full uniform load. So we'll come to wall load. This is what we want to apply. So we'll click on it. So this dialog box will appear. Then you come to this point, and choose user define. Yes, so user define. Then if you want to put in windows and the rest, from here you put it. But me, I don't like putting windows and the rest, because I want to design as what condition. So I don't normally like putting windows and the rest. So if you want to apply wall unit weight, so okay, so this is it now. This is wall unit weight. So wall unit weight, your wall unit weight, for wall unit weight, okay, for wall unit weight, we'll be having that. Okay, let me explain wall unit weight for you. So for 225 by 225, sorry, for 225 block wall, its wall unit weight is 2.87. That's the wall unit weight of a 225 block wall, 2.87. But you know that after placing your block wall, we will do plastering. Yes, so we will plaster both the front and the back. So the unit weight of plastering is 0.3. Of that plaster, the unit weight, that's the sand and the mortar, the unit weight is 0.3. So until you know, it will be 0.3, we'll be doing front and back. So it will be 0.3 plus 0.3, so which is now 0.6. That's the unit weight of the mortar and sand for front and back of the block wall. So let's now sum everything up now. So we'll get the unit weight of the block wall we'll be using. So in summing it up, we'll be having that the unit weight of block is 2.87. That's 225 by 225 block wall. That's 9 inches block wall. Its unit weight is 2.57. Then the unit weight of plaster, that is the sand and the mortar, is 0.3. We'll be having front and back, which is now 0.3 plus 0.3. We'll be having 0.6. Then 0.6 plus 2.87, you can press your calculator, you now be having 30.47. 0.6 plus 2.87, we're having 30.47. So we'll come here and input our unit weight to be 30.47. So this is our unit weight. So at this point now, they are asking us what is the height of our block wall. What is the height of our block wall? So the height of our block wall is 2.7 meters. 2.7 meters, that's the height of our block wall, 2.7 meters. Let me explain it to you. Sorry, is in millimeter, so it's 2,700. Since the unit is in millimeter, so it's 2,700. Let me explain it to you. You know that if you check our architectural plan, the height of story one is 3 meters. Okay, let me just click on insert and then go to the modeling and show you. So the thickness of our block, we're using the thickness of block of 225 by 225. So I'll click on 225 by 225. Don't click on insert. Just come here and click on this. You have applied it. Then I click on OK. Yes, so this is our block wall. But let me come to the 3D view and explain how I got that 2,700. So remember, the height of our story building is 3 meters. That's the first floor. That is from this slab now, from the top of this slab to the end of here. This is our story height to the end of this beam, which is what? 3 meters. And remember, the block wall will start from the top of this. Will start from the top of this beam, that's the top of this slab, and end at the end here below this beam. While the height level is from this slab to this height here to the top of this beam. So remember, in our wall load, we'll do 30,000. That is the height of this story from this slab to this top here, minus this beam depth, which is 300. If you now do 3,000 minus 300, we'll be having 2,700. So that's how I got this 2,700, that I use my wall load height. So right now, what we'll now do is that, see, this is what we now have here. We will now come and click on, we will now apply wall load to all these beams wherever we are having wall load. So I'll just click on this. Sorry. So I'll just come here. Okay, I'll click on this. Right click on copy load. I'll say okay. So I've copied this load now. Then I'll be having this wall load here. I'll hold my control key. I'll be having this wall load here. Hold my control key. Okay, let me just select everything. Let me select everything here. Hold my shift key. Select everything. Then okay, let me allow you to select. Then I'll now hold my control key and deselect the beams I don't want them to select. I don't want it to select this beam, so I'll not be having higher load on this. And I don't also remember, if you apply wall load here, that means you are applying wall load on the room. Let's go and check. So look at it. If you apply wall load there, this is the second floor. If you apply wall load there, look at it. That means you're applying wall here. So we'll apply line load. Don't worry, you see what I will do. So let me come back to my ProtaStructure. Let me hold my shift key and this. Let me hold my control key and deselect this. I'll deselect this. I'll deselect this. Sorry, hey, I shouldn't have deselected this and also this. This too has wall load. Yes, it's just okay. After I apply that wall load personally, I'll deselect this. I also deselect this. Remember, this is staircase. There is no wall load at the entrance of this staircase, so I'll deselect it. And remember, this is my story building. This is my sit out. There is no wall load here. I will deselect it. There is wall load here, but I'll still apply it after. I think yeah, true. We are true. After I'll still apply this wall load. So there's no wall load here. Yes, after I'll say apply this wall load because there's wall load there. So okay, let's go and check set to know whether are we having wall load here and here. Let's check. So we'll not be doing guesswork. So if you can see, yes, we're having wall load here and here. So we are still on track. So after I apply wall load to this. So right now I'll then now click on, you can either come here. If you're using ProtaStructure 2025, you can just come here and click on paste load, or you just right click and click on paste load. So yes, I'm through. Yeah. So remember, we mistakenly read this. So I'll come here and click on paste load. That thing I told you. So we have that from here to here. We'll be having wall load on this. So I'll just click from here to here. There is wall load. Why from here to here is the sit out veranda. So there's no wall load. So I'll click on this. Come here and click on insert wall by dragging. I'll click on this. Then I'll now from here to here. This is where I want wall load to be. So I'm through. So yes, this is what I'm having. So I've applied wall load to this. But don't forget, here we'll be having block wall. We'll be having a block wall here. Oh, sorry, let me delete this wall load. Delete road. There's no wall load there. Okay. So I have to it's okay now. So remember, here now at this edge, there is block wall along this edge. So but we cannot apply block wall here. What to now apply here is line load. Line load. So I'll now come to my loading. Come here and click on point and line load. Come here and click on line load. So what is the magnitude of that load? So to get the magnitude of this load, what you do is the height of the block wall times the unit weight of block wall. Or look at another way you can get it. Or you just come here, right click on edit road. The dialog box will appear. You click on this. So you click on this. So look at it. Once we inputted this at 3.47 and 2700 millimeter, it automatically calculated our wall load for us, like our unit load of the wall for us. Look at it here. Average load is now 9.369, which is this times this. But first of all, convert this into meter. That's 2.7 meter times 3.47 kilonewton per meter square. So if you multiply both of them, this is the load they are asking us to apply. This is the load we are going to apply in form of line load. That's 9.3, but I'll just call it 9.4. So I'll just come here, click on OK. So then I will come back again under my loading. I'll click on line load. That's 9.4. Don't forget, under line load here, I'll click on 9.4. So 9.4. I'll then come here at this edge, apply my load from here to here. Apply my load from here to okay, yeah, is it? We are still on the track from here to here. Then apply my load from here to here. Then apply my load from here to here. Yes, so this is what we'll be having. But don't forget, this one now, here is no longer block wall. Here is not handrail. We'll be having handrail here. So for handrail, I'll just like to use the unit weight of 1. I'll just like to use 1. This is not block wall. This is handrail. So so if you use 9.4, you are overloading this slab. So I'll also have this. Hope you understand this. So I'll now close. Let's go to our 3D view. So our 3D view, this is what we'll be having. This is that line load applied in form of wall. Then this is the slab load. This is the handrail. If you can see, it's very, very small. It's because we have already applied we have already applied this 9 load before. So this one is 9 point something, this one is 1 point something. So that this one is 1.0. So that's why it's very, very small. And at this point, what we'll be doing next, okay, let's go back to our model. At this point, what we'll be doing next is to arrange this thing to be ready for analysis and design. So next thing that we'll be doing next is that let's go to our, okay, let's go to building set out. Under story, we want to indicate our foundation depth. I'll come to option, I'll come to insert, sorry, not insert story, cancel. I'll come to option, come to edit story, So at edit story now, I want my foundation depth from the design report. The foundation depth should be 1200. So this is the foundation depth that I'm having. Then from here, the height of, look at it now, the height of my story, I'm having it as well 300 3 meter, which is okay, which is what I have in my architectural plan. Then if you look at it, they say this is imposed load reduction, but this is not really necessary here, because imposed load reduction is used in high-rise building. Because in high-rise building, something like, let me say 10-story building, in 10-story building, maybe say in the 10th floor, in that 10th floor might not always be used. Maybe when you're using 10th floor, when 10th floor is in use, the 9th floor won't be in use. So we do apply imposed load reduction in high-rise building to automatically reduce the load. You just come here and click on apply, but that one, this is beyond the scope of this, because this is just a duplex design. But just know that this imposed load design is for high-rise building where you want to reduce load, because in high-rise building, our aim is to reduce load coming down. So if you want to reduce load, the things that you can do is that you can use, instead of using solid slab, you can change your slab to waffle or flat slab, because waffle and flat slab have a lower weight or a lower load, or any of them. So, or you can, instead of using block walls, you can be using partition walls. Let me say when you get to story 6 and so 7, you can be using partition walls instead of using block walls. And so this is our way to reduce building. And also after doing those things, you then come and apply this imposed load reduction. But this is beyond the scope of this lesson, so let's just stick to this. So we are through with everything we're having here. Then click on OK. So I'll just click on yes. So after I've edited my height and everything, next thing to do now is to edit this test. Next thing to do now, okay, I'll be this story 1. Next thing to do now is to arrange the test of this thing now. Look at, I'm having bin 1, bin 2, yes, bin 3 is okay. So here should be bin 4, but I'm having bin 8. This here should be bin 4. Okay, so this one should be bin 4, bin 5, bin 6. So I want to arrange the test. Even the column, I'm having column 1, column 2, column 3, column 4 is okay, column 5, okay, column test is okay. But I want to arrange the beam test and the slab test. So in terms of detailing, I can easily detail it. So to arrange them, I'll just come to review to arrange the test. Don't worry, you see, understand what I'm doing now. I'll arrange the test. Okay, let me see something. If you are seeing, look at, after 1, 2, 3, I'm now having, okay, here is 9, 8, 7, 6, here is now 5. You see, it's not even arranged. Here is now 10, 26. But let me go arrange it so it will be easily. So I can easily. So once it comes to detailing, it will be easy for me. So I've already done axis before. I won't check axis again. I'll just check all these ones. Share wall. I'll just check all of them. I'll just come here and click on OK. So so if you look at it now, I'm having okay. This one is 1, 2, 3, 4, 5, 6 is now well arranged. 6, 7, 8, 9, 10, 11, 12, 13. So it's now well arranged. That's the reason for arranging our build, so that once it comes to detailing, I'll be faster in my detailing. So this is the main reason I do arrange. Then after, next thing I will do is I want to arrange the lettering of this. If you can see, it's inside the block hole, so I'll write it to be outside the block hole, and I'll not like all this 225 by 225 to be showing. So I'll just come to setting. These are all my personal settings. I will come to setting. Under setting, I'll come to Rabe. I'll come to Rabe. Then this, I want it to be outside. I just click on it. If you just click on it, I want it to be outside. So it's not outside. I'll leave it. Then in this one, I'll click on hide. I'll like it to hide it. Then click on OK. So let's go back. Okay, I'll click on OK. So if you see that I'm no longer having 225 by 225, I'm just having C1 and 2. This is placed outside. So these are all the settings I normally like to have. Then next thing now is to go to analysis, to go and do building model check. You can look at it here. I want to do building model check to make sure that I'm not having any error in my analysis. So you can look at the modeling again. Let me turn off the grid line so you see the modeling very well. Let's go to display. Let's turn off everything so you really see and appreciate what we have done so far. Yes, so these are the things I'm having. I've been seeing our modeling now. Clean and neat. Beautiful. Fine. Clean and neat. Yes. 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 We have done a very good job. So let me turn on all my layers again. So next thing now is building model check. Yeah, building model check. So if you want to do building model check, we'll go to review. We'll click on building model check. We'll now click on start. So after our building model check, we are seeing that we are having two errors. So let's go and correct that error. We are seeing that we are having two errors. So what we are seeing here is that first error is that story one, slab 17 is too small, has a very small area. Slab 17, but this is not a major error. So but we will see and check. Slab 17 is having a very small area. So this is our first area. The next one is that story one, S9 and S8 are overlapping. So both of them 17, S9 and S8. I'll just click on cruise. So I'll just come here. Story one, S9 and S8. To easily locate it, I'll just come to slab. Just click on S8. So this. So they say S8 and S9. So this is my S8, and also that means I. He said they are overlapping. S9 and S8 are overlapping. That means I inputted double slab here. I mistakenly inputted two slab here. So this is the reason why you should be doing your building model analysis. So I'll just right click and delete one. Delete. Yes. You see, I've deleted one. Okay. You not delete. Sorry, let me delete it again. Right click. Okay, I right click delete. I have deleted one. Yes, I've deleted one. As you can see. So this is the reason why you should do your building model check. Yes, to know whether everything is correct. See, I mistakenly inputted, and to assuming I went on to do analysis, you see that all these beams they will be failing because load from two slab is coming to them. A load from slab 8 and slab 9 will be coming to them because these two slab are applied on this. So this is the reason why you should do your building model check. Next one is that S17 is too small. Look at the S17. They say yes, it's too small, but we cannot do anything about it. So therefore, we will ignore that error. Then we ignore that error because we cannot do anything. We cannot increase this slab, so we'll ignore it. But we have done this one. We have deleted this. So let's go and run the building analysis again to be sure that we are up to date. So we are still having one error, and the error is that, where is the error? The error is that story 1 slab 17 has a very small area. We have said that we cannot do anything on this, so I'll just click on close. So right now, if you can remember, let me say something. If you can remember, in story 2, we did not do anything like fixed end moment, fixed end moment, summation of moment is equal to 0. The reason why we did not do it is because I know that it will pass. Like I've done a lot of design, and two, I know that since I've not been doing fixed end moment, like I've always been getting 2y16. So that's why I no bother doing it. Even the application of parapet road, I no so bother applying it because I know I'll still be getting 2y16. Okay, in fact, let's do the one of parapet road. Let's just apply a block wall of height 1 meter. So you see that also after design that it will stay pass. So let's just apply it. I'll click on it. I'll then right click. I'll go to edit road. Once this dialog box appears, I'll come to wall road. I'll come and change this my wall height. I'll change my wall height to 100 to 1 meter. I'll then click here. I'll then click on OK. I'll click on OK. Yes, so I've applied this. Let's see it in our 3D view. So look at it in our 3D view. So this is just my parapet road. I'm using this block as my parapet road. So I'll now paste it around the perimeters of this my building. So I'll hold my control key and select them all. So I selected column. Let me click on escape. So I'll hold my control key and then select everything, all the outer beams where I'll be having parapet. So I'll select them. Yeah, I selected them. I'll select them. Then I'll deselect this. I'll also come here, select this. Then don't worry, let's continue first. I'll select this and I'll also select this. So I've selected the whole perimeter. Let me hold my shift key. Okay, I've deselected this. So I'll now click on, I'll just try paste road. I'll then paste my road. Click on escape. If you see, they have pasted road round it. Okay, not paste road here. I'll click on this and click on paste road. So then at this point, I'll do drag road. So I'll just come and click on insert wall road by dragging. I'll move from here to here. Is okay. Then also for insert road by dragging, I'll move from here to, so I'll click on insert wall by dragging. I'll move from here to this point. So it's okay. So I've applied, okay, I'll see this one. So I'll move from, I'll click on insert wall by dragging, then move from here to here. So right now I've applied all this parapet road. So look at it in our 3D view. So this is it in our 3D view. Okay, not apply here, I'll say apply it here. So this is it in our 3D view. This is it. Let me apply that one I missed out on. Look at it. I'll click on insert road by dragging. So I will select this. I'll click on insert wall by dragging from here to here. So this is what I'm having. Let's go and see it in our 3D view. So this is what we're having in our 3D view. Let me turn off everything so you see it. But I know normally, I know if I'm doing a personal design, I will not apply this roof. I will not apply this parapet roof because I know even after I finish applying it, my design will still be passing. I'll still be having 2x16 in the beams. So that's why I don't normally bother applying it. But I just apply this because this is a tutorial, so people will follow on. Yes, so this is what we're having now. See how clear our model is. Yes, so let's go back and continue. Let's turn on our layers back. Let's turn them on. We're going to turn on every single thing. Yes, this is what we're having now. This is what we're having. And we have come to the end of this lecture. Remember, you can get the CAD file of this architectural plan in the link on the description below and practice on your own. Remember, the CAD file comes with both architectural plan and the structural design or the structural drawing of this architectural building. So you get to learn. Even when you're making mistake, you can reference the structural drawing and be up to date.